Hi everyone. Okay, so it's finally time to do this, the electric universe. It's been on my to-do list for ages, but it's been really hard to get going because, well, there's just nothing to address. But I'll see what I can do. I mean, it's hard to know where to begin because everyone says different things. Anyway, for those unaware, the electric universe is a pseudoscientific cosmological model according to which the electromagnetic force, not gravity, is the dominant force at large scales. The point is to get rid of the Big Bang, which they refer to as creationism. The universe can't have a beginning. That would be religion. In real science, the universe must be eternal. That's dogma. See what's wrong with that? Anyway, this is a model where the universe is eternal and does not expand, so it's incompatible with empirical facts. But more than that, it basically regards modern cosmology as a huge conspiracy, because it can't possibly be that the electric universe is wrong, now can it? No, it's being covered up. It's being kept out of the textbooks despite the fact that everyone knows it's actually true, because following Einstein is some sort of dogma, or something like that. Not only is this a field of not even wrong pseudoscience, it's also hard to find out exactly what proponents of this nonsense believe. I mean, for starters, one guy will say that gravity is a myth, gravity doesn't exist, gravity is a lie. And in his next video or blog post, he'll say that it's a misconception that EU proponents deny the existence of gravity, that they only deny its role as the dominant force at large scales. As such, whatever I say about it will be met with cries of straw man. So what I decided to do was to go to one of the de facto authorities on the subject, Mr. Wallace Thornhill, yes, Mr., not Doctor, and address his own written presentation, Electric Gravity in an Electric Universe Registered Trademark, found at holoscience.com. I'm linking to it below. Before I even begin, what's up with the registered trademark? No one trademarked Big Bang, general relativity, or even more specific ideas like lambda CDM. Because they're scientific ideas, meant to be explored by others. They're not meant to be anyone's intellectual property. That would be counterproductive, because it would prevent others from contributing to it. It's not going to contribute to increasing the knowledge of mankind. And that's the ultimate goal of science. You're just trying to make money, aren't you? Red flag straight away. Now let's begin.
If a special geometry has to be invented in order to account for a falling apple, even Newton might be appalled at the complications which would ensue when really difficult problems are tackled. Sir Oliver Lodge, FRS, 1921.
So what? First, Newton and Lodge are hardly relevant authorities on this subject. This quote is a century old, and since then, general relativity has passed every test it's been subjected to. And a lot of those tests hadn't even been proposed at that time. For example, the 2017 Nobel Prize in Physics was for the first direct measurement of gravitational waves, a prediction of general relativity that we, until then, simply didn't have the technology to test. Einstein himself said he never thought that gravitational waves would be measured. They're just too weak. But well, there you go. Second, Einstein didn't invent any special geometry. The mathematics of non-Euclidean manifolds was invented by others before him, including Gauss, Riemann, and Ricci. He only realized that with that math, he could give a better description of gravity than Newton could, one that took relativistic effects into account. Here are some examples of articles with descriptions of tests of general relativity. All of them are available in full text online, and all of them were found within a matter of minutes. If you want more, they're not hard to find.
Gravity is the most familiar force. We are subject to it every day of our lives. Newton gave us his law of gravity, which describes its effect, but doesn't explain it. I frame no hypotheses, he wrote. Einstein wasn't so prudent when he introduced his postulates. Unfortunately, his unreal geometry doesn't explain gravity either.
Why assert that it's unreal? But no theory explains anything completely. There's always room for, yes, but why is it that way? Also, no one claims that general relativity is a complete explanation, only that it's the best one we currently have, and the only one that consistently makes accurate predictions about gravity, except at the quantum scale, where currently no theory does.
The usual demonstration using heavy steel balls on a rubber sheet to represent gravity wells relies on gravity as its own explanation.
That's just an analogy, it's not the actual explanation. I think we can already safely say that Thornhill has not even opened a general relativity textbook. In general relativity, the curvature of space-time is not caused by gravity. It is gravity. If you want to have a look at a proper general relativity textbook but don't feel like paying for it, Sean Carroll's lecture notes are available for free online. It's basically a textbook minus the exercises. I'm linking to it below. Feel free to tell me where it, or any other GR textbook, mentions that the curvature of space-time is caused by gravity.
The fact that we do not understand gravity in the space age should cause alarm. Our cosmology, our view of our situation in the universe, is based on a mystery. The Big Bang is a monumentally expensive work of fiction.
But we do understand gravity very well. You clearly don't, but we collectively have a very good understanding of it. Again, it's not complete, but that doesn't mean that gravity is a mystery. Also, science starts at the top, with what's visible to us, with what we can test directly, and works its way down toward a foundation. The foundation of nature, or some aspect of it, is not what our knowledge is based on. Our knowledge is based on empirical fact. And how do you get to the Big Bang being a work of fiction? By using that word, you're explicitly not only claiming it's wrong, but that its proponents know that it's wrong. You're adopting a burden of proof, both to disprove what is, to say the least, a very successful theory, but also to prove malicious intent. Good luck with that. Here are some articles you might find interesting. These are of historical interest. And these are more recent articles presenting evidence consistent with the theory. All are available in full text online. And once again, I found these within a matter of minutes. Feel free to look for more. It's not hard to find.
In the 20th century, technology perfected wireless communication and computers and got man into space, while fundamental science fell deeper into a black hole of complication, illogicality, and metaphysics. I consider the principal cause has been the usurping, since Einstein, of natural philosophy and physics by theoretical mathematicians.
That's because, as Einstein and other great physicists around the turn of the 20th century noticed, nature was a lot more complicated than they had thought. At the time, they thought that physics was pretty much complete, that there were just a couple of loose ends left to tie up, just a couple of minor things that needed to be explained. Unfortunately, the explanations that turned out to work opened up huge cans of worms called relativity and quantum mechanics. Our exploration of these fields led to the modern technology you're talking about, or at least its 21st century continuation. The information age is made possible by advances in quantum mechanics, which apparently isn't real physics because the math involved is above your head. It's clear from this and quotes like,
"Natural philosophy has withered in its confrontation with the modern fashion of mathematical metaphysics and computer games. Most of the discoveries now are merely computer-generated virtual reality, black holes, dark matter, dark energy, etc."
That you prefer natural philosophy to actual science. And it shows. What's the difference, you ask? Well, in natural philosophy, nature is described using philosophical arguments, and the judge of whether your conclusion is correct or not is the audience and your critics. Is your argument sound? Is it convincing? Does it rest on a solid foundation of definitions and axioms that your audience accepts? Well, in science, the audience is not the judge. Nature is. The experiment is the ultimate arbiter of what is an accurate description of nature. If your description doesn't correctly predict the outcome of the experiment, then your description is wrong, no matter how convincing your argument might seem. And if a prediction that doesn't make sense turns out to be correct, guess what? Nature doesn't make sense. It doesn't have to. It's under no obligation to give a damn about whether we stupid monkeys can wrap our puny brains around it. Sorry. And no, the fact that computers are used to model and simulate doesn't mean that the conclusions reached are computer-generated virtual reality. The simple fact is that if a hypothesis requires a lot of math work that would take an unreasonable amount of time for a human to do, using a computer is the best way to go. And this is done all the time in engineering as well, and you don't complain about that, do you?
Meanwhile, Einstein, perhaps to his credit, remained skeptical of his own work.
Indeed he was. You even quote him saying that he was expecting to be proven wrong. That's called being a good scientist. If you come up with something really revolutionary, just like you're doing, it probably is wrong. Most wild and crazy outside-the-box ideas are wrong. Einstein was a good skeptic, and he didn't expect his own work to be one of the few exceptions to the rule. But 65 years after his death, his theory holds up better than ever. Like I said, it's been subject to tests that weren't available during his lifetime, and it keeps passing with flying colors.
I have always found it instructive to read what past luminaries of science thought of a radically new idea. The free exchange of opposing opinions is later stifled by the bandwagon effect.
Yes, of course. When an idea passes the test of time and becomes widely accepted, it's just a bandwagon effect. The reason chemists don't believe that you can produce gold by mixing chemicals in a beaker is just a bandwagon effect. The reason why medical doctors accept germ theory is also just a bandwagon effect. Medical science was much better back before germ theory became dogma and doctors were still allowed to think freely.
Bring out your dead!
Look, scientific consensus is reached because, as more and more research is done, we zero in on an accurate description of nature, the truth, if you will. Alternatives are discarded not because they are blasphemy, but because they are meant to replace something that demonstrably works without working as well themselves.
Einstein, in his special theory of relativity, postulated there was no medium called the ether. But Maxwell's theory of electromagnetism requires it.
False and false. The two postulates of special relativity are that in all inertial frames of reference, 1. The laws of physics are the same, and 2. The speed of light in vacuum is invariant. The irony is that the second is taken from Maxwell's theory of electromagnetism. According to it, C equals 1 over the square root of mu naught epsilon naught, a formula that includes no variables, only constants describing the electromagnetic properties of vacuum. Because there are no variables here, that means that the speed of light cannot depend on the observer's motion relative to the source, or anything else for that matter, making it invariant. Einstein didn't postulate that the ether didn't exist, he simply realized that it was a superfluous concept and got rid of it. There's no need to postulate the non-existence of something that is simply never indicated, and which has also been experimentally falsified. Finally, the only reason why Maxwell's theory appears to require a medium for light to propagate is that Maxwell didn't know that light has particle properties, and particles have no problem moving through vacuum. You're not just denying relativity, you are, with a few cherry-picked exceptions perhaps, rejecting all physics discovered after about 1900.
So Einstein, at a stroke, removed any possibility that he or his followers would find a link between electromagnetism and gravity. It served the egos of his followers to consecrate Einstein's ideas and treat dissent as blasphemy.
What stops others from looking for a link between electromagnetism and gravity isn't that it's blasphemy, but that the case against it is so strong that it's really not worth it. Just like there's not much point exploring astrology, vitalism, alchemy, intelligent design, or the stork theory of human reproduction. But guess what? No matter how silly it sounds, you are allowed to do it. It's just that if you want to be taken seriously, you need to have something better to say than, "Wah, conspiracy!" Crying conspiracy does nothing to strengthen your case.
Yes, it does!
What the? Uh-oh.
The problem has been worsened by the particle physicists who indulge in their own virtual reality, inventing virtual particles to transmit forces.
Although they can't be detected directly, that's why they're called virtual, they can be shown to exist indirectly. A great example is the Casimir effect, which is the result of particles popping in and out of existence in vacuum due to the energy-time uncertainty relation. producing measurable pressure in vacuum.
In 1850, Faraday performed experiments trying to link gravity with electromagnetism that were unsuccessful.
Gee, I wonder why.
Because his success was covered up, obviously.
Faraday's estimate of the importance of such a connection still stands. After all, the electrical and gravitational forces share fundamental characteristics. They both diminish with the inverse square of the distance, they are both proportional to the product of the interacting masses or charges, and both forces act along the line between them.
Yes, but you're talking about Newtonian gravity, which is only an approximation that happens to work well for many, but not all applications. By restricting yourself to arguing against an outdated theory, you're committing a straw man fallacy.
Gravity acts in proportion to the mass of an object. What do we mean when we refer to the mass of an object?
Mass is a measurement of a system's total inertia, or its resistance to being accelerated by a force, F equals ma. It's related to the system's rest energy, E naught, through E naught equals mc squared, or total energy in the case of relativistic mass.
Early in the 20th century, numerous textbooks equated the mass of an object to its weight. That equation led to confusion because it doesn't explain why the mass of an object we measure on a weighing machine, gravitational mass, is identical to the mass of that object when we push it, inertial mass.
And no one defines mass as weight anymore. But fair point. Why is gravitational mass equal to inertial mass? Let's have a go at it, shall we? Let's call the acceleration due to gravity g. Newton's second law then gives us gravitational mass times gravitational acceleration equals inertial mass times total acceleration. Empirical observation tells us that the gravitational acceleration equals the total acceleration of any system because all objects accelerate equally during free fall. It follows from these two equations that gravitational mass equals inertial mass. In other words, the answer to the question is really because if they were not the same, the universe would not behave the way we observe that it does. We're trying to describe this universe, so our concepts must be built so that we can successfully do so. If you want an answer to why does the universe behave the way it does instead of some other way, then you're out of luck. Whether you're talking about gravity or electromagnetism. I mean, why do positive and negative charges attract each other? Whatever answer you give to that question, I can ask, sure, but why is it that way? And reject your answer because it's incomplete. But of course, that would be stupid, wouldn't it?
When it was found that atoms are composed of charged particles, there were attempts to explain mass in terms of electromagnetism. It makes good sense that the equivalence of gravitational and inertial mass should be explained by the electrical structure of matter.
Sure, I suppose I agree that if you only take the physics that was known at that point into account, it sounds like that could make sense, and that it's a reasonable hypothesis. But that didn't go too well now, did it? What makes sense to us stupid monkeys whose idea of common sense has evolved to deal with predator bad, food good, boobs awesome, isn't what matters in science. What matters is what makes successful predictions, that is, what works when actually applied in practice. Boobs awesome.
However, it's not the philosophical concept of mass, but its mathematical treatment that occupies physicists.
Right, because philosophical concepts tend not to make predictions about the outcomes of scientific experiments. You need mathematical formalism to have formulas, and you need formulas so that you can plug numbers in and actually get a useful result that you can compare against empirical measurements. Do you treat current as a purely philosophical concept? How then do you determine what fuse to use, or what resistor, what coil? How do you determine which components you need in a circuit to make a device work as intended? Just trial and error? Philosophical arguments? No, you calculate. You can't do physics without doing the math. Sorry. I know a lot of people don't like that, and it's what scares a lot of people away from physics, but that's just the nature of physics. Yes, even if it's a part of physics that you don't understand.
Textbooks and encyclopedias today slip unnoticeably into the error of using the words mass and matter interchangeably. A NASA educational website tells us that mass is a measure of how much matter a planet is made of. It shows that the confusion of mass with quantity of matter infects astrophysics.
But this is an explanation, not a definition. And it's not a bad explanation, because if I have a body and I accelerate it with a force F to give it acceleration A, and then add an identical body, doubling the amount of matter of the system, I must now push with a force 2F in order to give the resulting body the same acceleration. The problem is that amount of matter is ambiguous.
The mass of a celestial body cannot tell us about its composition. We cannot say what the sun is made from.
The mass alone can't, you're right. No one claims that we know what the sun consists of based purely on its mass. The most important tool for knowing the composition of the sun is spectrometry.
Another example is comet nuclei, which are electrically charged bodies.
Everything I've ever heard about comets says otherwise, so citation definitely needed.
Some guy on the internet said so!
They register masses that should have them constructed like an empty sponge, yet they look like solid rock.
No, comets have rock in them, but ice contributes more to a comet's mass than rock. A lot of mass also comes from various organic compounds. We've landed a probe on a comet. If you're going to claim that the findings reported were fraudulent, I ask that you back that up with actual evidence, not just assertions.
Hey! Some guy on the internet said so, and he's written books too, and he has no relevant qualifications, so he's not in on this conspiracy.
Right, that's what it always comes down to. If someone has qualifications, in other words, if they have knowledge that goes above the conspiracist's head, then that knowledge can be dismissed as a lie. The conspiracist operates under the assumption that they know everything. Flat earthers know that high school trigonometry is a lie because it's beyond them. This is no different. EU proponents reject modern physics as a lie because they don't understand it, and it's easier to cry conspiracy than it is to go to school and educate oneself, or to accept the knowledge of those who did. Recognizing expertise isn't being an unthinking sheep. You are free to challenge experts, but you have to accept that the first thing you must do if experts present information that goes above your head is educate yourself to their level. Otherwise, the likely reason why you think they're wrong is that you simply don't understand them.
It is their appearance, together with the recently recovered high-temperature minerals, rock particles, from a comet, that gives the accurate picture.
Sure, the appearance is more important than actual measurements. Just give up.
I will not!
This inexcusable philosophical muddle over matter and mass has given rise to violation of the fundamental physics principle of no creation or annihilation of matter.
There is no such principle, and if there were, it would be demonstrably false. Matter is not a conserved quantity. Energy, momentum, and charge are examples of conserved quantities, but neither mass nor amount of substance has to be conserved in a physical reaction. For an obvious example, the reason why nuclear reactions give off energy that can then be harnessed is that mass typically is not conserved in nuclear reactions. The missing mass is where the energy comes from. E equals mc squared, remember?
It has allowed a miraculous cosmological creation story to gain currency known as the Big Bang. Notions of vacuum energy and particles winking in and out of existence in the vacuum of space are similarly miraculous.
Whether you think it sounds miraculous or not is irrelevant to whether the evidence supports it. And it does.
The simple fact is that we have no concept of why matter manifests with mass.
I suppose I could mention the Higgs field, but you would only say, yeah, but why would that be? So why is simply not the right question to ask. And I'm sure you don't ask it with regard to charge, for example.
Without accepting his model in its entirety, I consider Ralph Sansbury's straightforward electrical theory of magnetism and gravity to have conceptual merit. Simply stated, all subatomic particles, including the electron, are resonant systems of orbiting smaller electric charges of opposite polarity that sum to the charge of that particle. These smaller electric charges he calls subtrons.
Okay, great! Let's test that hypothesis. I'll wait.
Electromagnetic waves are far too slow to be the only means of signaling in an immense universe. Gravity requires the near instantaneous character of the electric force to form stable systems like our solar systems and spiral galaxies. Gravitationally, the Earth sees the Sun where it is this instant, not where it was more than 8 minutes ago. Newton's famous law of gravity does not refer to time.
What? How can you fit that much wrong into that little text? Both gravity and the electromagnetic force propagate at the speed of light. This is part of what led Einstein to develop general relativity in the first place. He saw that because, since in Newton's theory, gravity propagates faster than light, that theory was incompatible with his own theory of relativity, what's now called special relativity.
Gravity is due to radially oriented electrostatic dipoles inside the Earth's protons, neutrons, and electrons. The force between any two aligned electrostatic dipoles varies inversely as the fourth power of the distance between them, and the combined force of similarly aligned electrostatic dipoles over a given surface is squared. The result is that the dipole-dipole force, which varies inversely as the fourth power between collinear dipoles, becomes the familiar inverse square force of gravity for extended bodies.
If I understand this correctly, these dipole moments are not the permanent ones, but are induced by the respective body's dipole fields. For an extended body, yeah, I can see how that would give you the same dimension as with the inverse square law, but that's it. The size of the body's cross-sections will have nothing to do with the distance between them, so the numbers simply won't add up.
The gravitational and inertial response of matter can be seen to be due to an identical cause.
It can? Where? How? I don't see how dipole moments can have anything to do with inertia, and you're just asserting it. Mass relates to it by the definition of mass, which we've already covered. But we have not established that dipole moments relate to mass. It sounds to me like you're just trying to hand-wave this rather important detail.
The mass of a body is an electrical variable, just like a proton in a particle accelerator. Therefore, the so-called gravitational constant, g, with the peculiar dimension length cubed over mass times time squared, is a variable. That's why g is so difficult to pin down.
But it's not difficult to pin down. It's a constant with a well-known value determined experimentally, and the dimension of it is no more peculiar than what you get if you replace mass with charge. That would give you the dimension of the constant in Coulomb's law. You don't complain about that, do you? Also, it seems like I was right in that you're talking about mass being a function of an induced dipole moment. Since energy is a function of mass, please explain how two dipoles attracting each other, moving toward each other with no external work being done, won't violate energy conservation. Their masses and thus their rest energy will increase as they move closer together because one will induce a stronger dipole moment in the other and vice versa. How is that possible without the energy being supplied through external work? Because if they attract each other, that happens spontaneously, and that would violate both the first and second laws of thermodynamics.
Despite a number of experiments demonstrating anti-gravity effects, no one has been able to convince scientists attached to general relativity that they have been able to modify gravity. This seems to be a case of turning a blind eye to unwelcome evidence. Support for anti-gravity implicitly undermines Einstein's theory.
No, anti-gravity has never been demonstrated. The source cited for this claim is Evgeny Pokletnov, I hope I'm pronouncing that right, who claims that rotating superconductors shield against gravity. But the key word here is claims. His experiments have never been successfully reproduced by others.
Look, I'm not saying it was cover-up, but cover-up.
Yeah, that's what he says. Look, seriously, if this were about some other claim, about something you had a little more knowledge of, you'd never accept the "it's a conspiracy" excuse. Say I claim to have devised an experiment that proves that positive and negative charges repel each other. That would obviously have huge consequences and you'd rightfully be very skeptical, especially since it flies in the face of very well-established physics. you'd demand to know how it was done. If I explained the experiment to your satisfaction, you'd still want independent confirmation because you'd be under the assumption that although the experiment seems fine, I probably made a bad measurement somewhere, or a wire was loose, or something like that, right? And when others then replicate my experiment and don't get the results I claimed to get, what's more likely? That I did something wrong, intentionally or by mistake? Or that all of electromagnetic theory, which is well established for a huge number of very good reasons, is not only wrong, but a dogma that the establishment defends despite knowing it's actually false? If I bitch about there being a conspiracy, you're not going to take me seriously. But when you're on the other side, you expect to be taken seriously. The usual special pleading of the pseudoscientist. Science is right, but only when I like it.
Gravity must act instantly for the planets to orbit the Sun in a stable fashion. If the Earth were attracted to where the Sun appears in the sky, it would be orbiting a largely empty space because the Sun moves on in the 8.3 minutes it takes for sunlight to reach the Earth. If gravity operated at the speed of light, all planets would experience a torque that would sling them out of the solar system in a few thousand years. Clearly that doesn't happen.
Why would that happen? I'm sorry, I don't have a better response. It just seems like you don't understand the relativity of simultaneity. As far as the Earth is concerned, the Sun is really where you might say it was 8 minutes ago if you're not thinking relativistically. The Sun being elsewhere now in its own frame of reference is completely irrelevant. The concept of now is not the same in the two frames. In fact, the frame where the Sun is 8 minutes ahead of where it appears to be is a pure construct without empirical reality. There is no torque like the one you mentioned because the effect of the Sun being 8 minutes ahead of where it appears to be won't reach us until 8 minutes from now. It's no wonder you reject relativity when you clearly don't even have an undergraduate level understanding of it.
Einstein's postulates are wrong. Matter has no effect on empty space.
That's not one of Einstein's postulates, but yes, it does. It's measurable. Gravitational lensing, redshift, and time dilation are all measurable phenomena.
Space is three-dimensional, something our senses tell us.
Sure. Setting aside the proposed extra dimensions of string theory, that's a completely separate issue, space is indeed three-dimensional, making space-time four-dimensional. The three dimensions of space plus time. 3 plus 1 equals 4. Now, please tell me who the hell says otherwise.
There is a universal clock, so time travel and variable aging is impossible. Something that common sense has always told us.
No, there isn't, and that's been demonstrated experimentally on numerous occasions, both directly using atomic clocks on jet planes and satellites, especially GPS satellites, where it's actually important continuously because clocks aboard the satellite need to be synced with clocks on the planet below, and that means you have to adjust for the time dilation. But it's also been tested indirectly by looking at other predictions of general and special relativity that are based on this.
If I can use a simple analogy, light travels slowly like the transverse ripples on a pond surface. Gravity travels swiftly and longitudinally like the speed of sound in water. Once again, this is at odds with Einstein's metaphysics because it reinstates Maxwell's ether. Maxwell's electromagnetic theory requires a medium. How can you wave nothing?
Then not only is the analogy a bad one, you're treating it like it's a literal similarity. Quantum theory, specifically wave-particle duality, explains how light can travel through vacuum. Particles can travel through vacuum. It's not nothing that's waving, but the probability of finding the particle in a particular state. Basically, the math describing the evolution of a quantum system is the same as the math describing waves. That's why particles exhibit wave-like behavior. But yeah, I know, math was made up by NASA to prove that the Earth is round, right?
Yeah! That's right! Wait. Was that sarcasm?
The Michelson Morley basement experiment was heralded as having lain to rest the notion of an ether. It didn't. Dayton Miller carried out far more rigorous repeats of that experiment at different locations and elevations. He found a residual, which allowed him to conclude that ponderable bodies like the Earth drag the ether with them. He was able to determine the relative motion of the solar system with respect to the ether.
And when others, such as Robert Shankland and later Tom Roberts, analyzed his findings, they found no statistically significant result. Also, Miller's result is incompatible, not just with the original experiment, but also with later, much more rigorous versions of it. A list of such experiments with sources can be found on Wikipedia. Link below.
Cover up!
Based upon nuclear experiments, I have also proposed that neutrinos are the most collapsed, lowest energy state of matter. In other words, they exhibit vanishingly small mass. However, being normal matter composed of subtrons, they are capable of forming electric dipoles.
Subatrons are just conjecture. They have not been shown to exist, so you can't say neutrinos are composed of them. Nor can you claim they are capable of forming electric dipoles, only that they should be if your conjecture is correct. This statement of yours implies that you have evidence supporting your conjecture, so citation needed.
A guy on the Hey!
In an oscillating electromagnetic field, a neutrino must rotate through 360 degrees per cycle. That would link the speed of light in a vacuum to the moment of inertia of a neutrino. Having some mass, neutrinos must be dragged along by gravitating bodies. They form a kind of extended atmosphere which will bend light. It has nothing to do with a metaphysical warping of space.
Okay, cool. Go ahead and test that hypothesis. If there are that many neutrinos that have such an obvious effect, that doesn't seem too hard. And we already have neutrino detectors, so why aren't they detecting an assload of unexpected neutrinos? Oh well, I'll wait.
No matter that there's an avalanche of books and papers supporting Big Bang cosmology, repetition provides no assurance that one particular interpretation of results is valid.
No, but what is repeated does. Maybe you should pay attention to it.
Assurance of interpretation can come only by comparing the success of competing hypotheses in interpreting data from disparate areas. Big Bang cosmology fails this test because it brooks no competition.
Tell me, Wallace, are you also going to complain about the fact that in the scientific community there is no competition to the spherical Earth model? I mean, if it were true, why is no competition allowed? I hope you're not that stupid. You do see the problem with competing against something that is firmly established, supported by all the evidence, which passes every test, and which is also directly observable, right? Well, there you go. You can see the hot, dense state of the early universe, just as we can see the curvature of the Earth.
For example, plasma cosmology is officially recognized by the largest professional organization in the world, the Institute of Electrical and Electronic Engineers, IEEE, while Big Bang cosmologists ignore it.
Why would cosmologists care what electrical engineers think about cosmology? You do know that electrical engineers study electrical engineering, right? Not cosmology. But that cosmologists do study cosmology, and not electrical engineering. I would have thought the names of the professions would provide you with some kind of clue.
Hey, electrical engineers know way more about cosmology than cosmologists, because they haven't been indoctrinated with the dogma of mainstream cosmology.
And by the same reasoning, cosmologists know more about electrical engineering than electrical engineers?
Oh, come on. Now you're being deliberately stupid.
The electric universe model is an extension of plasma cosmology. Registered trademark.
Yes, plasma cosmology is a fringe theory that downplays the role of gravity and proposes a steady-state universe. The electric universe is an extension that goes beyond the fringe. Straight into tinfoil hat land.
Yay! THL! THL! THL!
Big Bang cosmologists have no narrative that can compete.
No, indeed, they do not have a narrative that can compete with an exciting conspiracy theory and a model that sounds like it makes intuitive sense and can be understood without a bunch of doctorate-level math. What they do have is evidence. You keep your compelling narrative and tell your followers that they are good freethinkers for blindly rejecting the dogma of science and instead blindly accepting yours. Here, we don't care about narratives. We care about facts and the theories that successfully explain and predict them. Welcome to science. Have a nice day.
This is called gravity.